Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Welcome, gentlemen. My name is BBI and I work on amplifiers, and I don't care what kind. RF amps, any and all kinds. So what we're looking at today is a later old school Loudmouth. This kind of takes after the little Palomars and that kind of thing. We're using 6LF6 tubes in this. It's 1 drive and 3. That whole portion of the thing looks like it's okay. We're going to circle back around to that. We'll get out the ubiquitous 747 tube tester and we'll check all those tubes. He was kind enough to send me a match set of 4. I don't think we're going to need to get into those, but we will test these other four tubes with our tube tester just to re-verify the information that he's got going on. The reason this is here is this gentleman says that the input auto keying circuit went kaputzi on it. Now what I do have is some pictures that he was kind enough to provide me with, and it's all the pictures of the board before it was touched. Now he tried to repair this himself, him and a friend of his apparently, and they weren't very successful. And the reason I say that is because we've got this little bag of parts that's here, and they did the thing called the shotgun technique. Believe it or not, that's how I started repairing radios when I was a kid. Well, if I eventually replace enough parts, it will fix the problem. And in theory, that's how this works. If you do replace enough parts, eventually you'll get to the one that's broken. I had some very kind, nice gentlemen when I was younger explain to me that that's not really a practical way of doing it, and they said it was time for me to start learning a couple things. He says the current configuration that we've got going on here does click, 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 click is all it does. And I was like, oh. So we've got our snub and diode removed off of our primary relay, which this is for the high voltage. This is your keying relay, by the way. So the snubber off the high voltage relay here is disconnected for some reason. It's okay, we'll circle back to that. So this board has been extensively worked over. There's been quite a few parts on it changed. I have a feeling that it was this capacitor here they tried to change out. This electrolytic got changed. I have a sneaking feeling that this choke might be popped open because it's so discolored and blackened at this point. But we'll check that with a voltometer. Either way, we're going to replace it. This has two N2905As in it, which is a real close cousin to the 2N222 base emitter collector. This is basically the same pinout. A little bit higher current draw on the 2905. They've got new modern 2905s installed. And they've got the base, emitter, and collectors all in the right orientation. So, there's some kind of physical breakdown on this board. I want to check this inductor real quick. This one right here. We'll put a little bit beefier one in there. The solder work doesn't look too bad on this thing. I've seen worse. I really have. None of the traces are peeled up. These old school traces have a tendency, the foil on them just wads up real quick if you're not careful with your temperatures. So we're going to quickly run through that. And you know, on some of these older tube amplifiers, if the input reflect isn't set up just proper and you get too much reflect between the radio and the amplifier, it'll drive the key-in circuit crazy, and it'll sit there and go click, 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 click. I see the sideband switch was flipped up on this, and I bet you this is our sideband delay capacitor, this electrolytic that's here. I'll almost bet you anything. So let's see, that goes to this brown wire, and let's see, AM and sideband goes to the green wire. I could be wrong. Brown wire goes to operate standby. Let me unleash my feeble mind against this, and we'll see what we can come up with. Give me a couple minutes, and we'll give you a quick update here. So on all sweep tube amps, I found that about, and I'm pulling a number out of my ass, but I'd say a large majority of, I think I might have dropped my voltometer one too many a time here. A large majority of our problems come from the capacitors being so old. And usually the capacitor will dry out, the guy will go and flip the switch on, the high voltage will get engaged, and it'll just scatter the rectifier circuit, which is this here. So I like to just quickly go through and make sure I don't have any obvious shorts. And they're all at 0.5, 0.57, so that's a great sign. We have one other little diode that's snuck down in here. So then we can see the voltometer counting up. And then I like to reverse it. Yeah, we have no shorts. I think that this thing has finally come to the end of its useful life. See it counting up. So now if we reverse the leads, because that's a capacitor charging, so we're charging off the leads of the probes. So the next thing I like to do is just randomly go ahead and let's check all the inductors. Make sure we don't have anything open. This is for our grids on the tubes. And then we'll quickly come over here. We're going to check the inductor here. That's good. This little inductor that's here, that's good. And then we're going to go ahead and check our snub and diode on our transistor. That's looking good and solid. That transistor is good. Cool. Alright, so we're not obviously blown open in any way. So now what I'll do is I'll grab the pictures and I'm going to very quickly make sure that everything is orientated right, like the diodes are all in the right orientation on the keying board, that kind of thing. And I couldn't help but notice we got a couple little bad solder joints on here, which is not a big deal. Just take a couple minutes to fix, so it's not like we're going to get excited about it, because you know shit happens. Bad solder joints as in like the brown wire that comes from the operate standby switch just popped off. So I stated something in the previous segment. Actually, this board trips this relay. There's a third relay in here, which then in turn it trips this relay, which tells me this is a 110 volt probably relay. This is also a 110 volt relay. So we'll use this relay to trip this relay up against the wall, and I'm pretty sure that this relay also in turn trips that relay there. But we're using this as our preamp relay right here. So, see, we got the pink wire just broke off too. And this could be from us jerking it around so much, trying to move it around for camera, but it doesn't matter. If the joints are already so popped off and the wires are already so stiff, we need to redo these jumpers anyhow, because who's to say they won't fail in shipping, right? So this just running down the road in the back of the truck, vibrating. I want to come back. I'm going to reflow this joint here on this smaller relay here, and let me get out the rubbing alcohol and clean all this up. Make sure that we don't have a trace shorted over, and yeah, we'll put this back together so it's got ground reference on it, and then we'll check the tubes, and then we're going to see how it's operating. So here's another little thing that we got to keep an eye on is this here. You see this little white dot? So all capacitors have a vent on them, right? Especially these old actual lead ones. Got to keep an eye on that. That's the shmoo coming out of the can, the electrolyte that's coming out of the can that is our filter, part of our filtering electrolytic inside the can. Once that dries out, this can short out. And when that happens, that's when it blows the diodes, and it's just a downward progression of things. So I think we're okay. I might go ahead and pull this board up, disconnect one lead off both sides, and then go ahead and check the capacitance on this and these other two filter caps. So 50 volt 100 UF, 50 volt 100 UF. Okay, so that's our low voltage rectifier. That's our high voltage rectifier. So these boxes are so simple. Once you learn the basic operations of where the parts are, what the parts do, they might be in a different location in each amplifier, but the rough operation is the same. It really is, and it works all the way up to your bigger transmitter tubes, ceramics and glasses and that kind of stuff. It's all the same parts, just they're bigger, higher voltage rating, and you have to think a little bit differently because the voltages are extremely higher. This has got 600 to 800 volts on the anode, and the filament's around 6 volts on this because, well, it's a 6LF, 6LQ, 6J. They're all 6 volts, so easy peasy. All right, let me do some magic solder work and see if we can get this looking a little bit better. And I want to check the orientation of the snubber. And oh, hey, we've got a blown resistor here. This resistor right here has got a big old hole in the side of it. All right, so I need to do some resistance checking. Brown, brown, red. I'll be back. Okay, so we got all of this done over here. So what we found was this guy was a 1.1K. It now currently reads, with a voltometer that works, 217 ohms. So I would say that falls within the category of bad, that and it's physically got a flipping hole in the side of it, a little blackish. And this is a 470 ohm resistor, which reads pretty close to spec, but as we can all clearly see, it's a little discolored, as in like it's now brown in the middle. And I'm kind of the opinion that once a resistor gets hot enough to discolor, we should just go ahead and replace it. So anyhow, I found the exact same valued resistors. Of course, they're not the same exact resistor that was in here. I used mil-spec, pre-tested. Come to find out where I got all my resistor storage from comes from a missile research and test lab out of Phoenix, Arizona, because I had the guy that I bought them from at a Hamfest end up calling me down the road, and he goes, man, I got all those out of my research lab that I used to work for. He worked for Perkin-Elmer, but he was permanently on loan to Perkin-Elmer from Perkin-Elmer's optics department for some portion of the missile guidance program that was based out of Phoenix. And I bought them at a Hamfest from this guy in Phoenix through a friend of mine that was there. Anyhow, it's now got 1% mil standard, mil pre-tested Peter Dahl resistors in place of this. So I think we got all the bugs worked out. The filter capacitor that you guys had in there was not the right capacitance value. So one was 35 volt 50 UF, and the one that was in there was a 35 volt 22 UF. Replace that board with the appropriate cap. When we get back over here to looking at this, you'll see that I cleaned the board all up, redid all the solder traces, ran ahead and remounted everything, and then we replaced the all burned up resistor, which all this is doing is acting as an RF block as part of the keying circuit. So yeah, it's got conductivity, but we don't know how the massive heating has changed the magnetic permeability of the ferrite material that's in here, so I just went ahead and replaced it. Anyhow, let's do a quick check on the tubes. This is a 6LF6 that's been set up in here. Got my heater sensitivity set at 48, or my heater set at 6 for 6 volts. Sensitivity set at 48. We have no shorts, no grid missions issues. We're testing right at 70%. And we're going to do test number 2, and it's showing no results. So, this guy, which is now a little warm, we're going to clearly label for my sanity and for the gentleman that owns the amplifier's sanity 1, and then we're going to go 70%. And for all intents and purposes, that'll work just fine for us today, is what we're doing. Got like 14 different things going on today. I'm just trying to stay on track and get at least one thing completed, if that makes any sense. Okay, I gotta give this a couple minutes to warm up, let the filament heat up the glass. Filament heat up the glass, and we'll go from there. So weird, it looks like there's a smudge there on camera, but it's not. It's just play on light. No shorts, no grid emissions. Here we come. It's another thing I bought out of Hamfest in Phoenix. It's this tube tester. Of course, I had to go and completely recap it and then realign it. Thank you, B&K, for making it possible that we have the alignment procedures for all of this and the actual tech specs for this, or whoever actually put them on the internet, but thank you. I do actually have both the manuals, thank God. So, man, I'm gonna call that a 65, 66%. This will work for testing. So before I write, let's get this one started in its heat up process. These later model Loudmouths, there's 2 or 3 different versions of this Loudmouth amp, by the way, and we'll call this tube number 2, and we'll say 63%. This later model, because this is a later model, these are a cute little driver amp. You'd use like a Black Cat, or like, not a Black Cat, you'd use like a tram radio, something like that, very low power radio, just like 4 to 5 watts. You kick it into this and you can kick that up to a couple hundred pretty easy, and then from there you can run that into something else, and then you can play with the tram and do your stuff that you got to do to get it up, you know, maybe 100 watts or so reliably. All right, well, that's 68. 63. It's blowing the tube. Whenever you run a tube tester like this, you want to make sure that the air movement in the room that you're in is relatively stable. You don't want to have cold air blowing across the tube. It'll affect the test results. So tube number 3, and we'll say this is at 65%. All right, guys, last one. Short of us having a key-in transistor that is no MOS, the key-in transistor or the preamp transistor, short of those being bad, I feel relatively certain that that amp board, or the auto keyboard that's in that thing, is going to work. I want to fire it up and get some voltages off of it, though, and see where we're at. Ooh. Nothing. Nothing. All right. So, if you had this tube in the driver position, in this socket, let's say, this is our driver, and this is our final stage. So these 3 are our final stage, that's our driver. If this tube, which has 0 admissions on it, doesn't have shorts, none of that other stuff here, we'll even crank the sensitivity way up, crank it up to 100. If this tube was in the driver position, you would have an almost infinite input SWR. It'd be really high. And it caused the relay to have its malfunction that you were seeing in the junction. Okay, we're going to call this bad. No good. Oh, good. Okay. Well, let's go ahead and let's we'll take the virginality right off of these. Matched. 4 matched. Unused. The man says matched. Says unused. Ooh, Phillips. We'll randomly grab one out of the box. Oh, I smell the 50s and the 60s. Okay. You know, we put this in our driver spot, that way we can get the absolute max poop out of these other 3 tubes so it can look like a hero. Yeah, it's a Loudmouth 3-tuber that does a kilowatt, you know. Here we come. Okay, let's not push the button in. Let's let it just come up to temp. I hope you guys had a good Thanksgiving. I had a great Thanksgiving. Got to be with my whole family. Now, my sister was sick. My brother-in-law was sick. Now my daughter's sick. My niece and my nephew are now sick. My wife and I so far have managed to escape the ick. New, huh? Let's set that one aside for a control. We had this set at 63. We claimed it was at 63%. Let's see if we can replicate those results. New, huh? Here's the problem that we're running into, you guys. Is the market is flooded with stuff that looks new, but is not. Pretty close to 63 to me. Let's grab another new out of box. 100% good new old stock, supposedly. Interesting. 40%. It's in the bad admissions, by the way. Take and slide this back in its box. Just set this right here on camera for now. Holy doke. Come on. Come on, give it, Daddy. Give it up. 43%. Looks so good. I took a link to a YouTube video and put it up in Facebook the other day of these ladies working at Philips make vacuum sweep tubes. Television control tubes is what they were listed as on YouTube, because that's what they were actually used for. That was a neat video to watch. Pre-safety anything. It was solid lead asbestos exposure all the way around, right? Oh, oh. Keep going, keep going, keep going, keep going. 50, 50. Oh, oh. 50? 51? Give me 52. Give me 52. Give me 52. Nope. 51. And floating. Thinking about going to 52. Thinking about it. There's 52. Maybe. Here we can make it lie. It's got to be set right at 48. So we're looking at, that's the best one of the batch so far, 53%. Maybe we'll have chicken dinner winner here in a minute. I have a feeling it's going to be this one driving these three. We'll see. This one's a short though. This is no good. It's not a short, it's just got 0 emissions. So 0 grid. Come on. You can do it all night long. All you gotta do is push the needle past 60. Come on. You can do it. You can do it. Come on, tube. You can do it. Well, we're going to call that 21%. Okay, moving on. Okay. This has been a lot of fun. So far, I've had 1, 2, 3, this cap. These have been the major headaches for me. And this diode. All right, so we're working. We're 100% working now. It took a few minutes to get here, as in like a couple hours. So there was a few things that was wrong. I finally got the keying circuit figured out, but the input SWR was so high that this thing wasn't usable. And come to find out, this cap has been changed out. This cap, I don't know where it came from, but it wasn't in the original pictures. Somebody has changed out this cap. Now, in this pile of parts that were sent with the amp, this stuff here, I found a 20 picofarad cap. And I went, huh. So this cap, where it's at, is this is where it was installed, was a part of the RF sensing circuit for the keying circuit. And this was at 200 picofarads, so it made the input SWR almost completely infinite with the amp on or the amp off. So talking through the box, you would have been deaf. You wouldn't have been able to hear anything because of this one cap. This took a few minutes to work out, as in like about an hour or so. Man, I'm over here playing, trying to create an input tune network and stuff, and I thought, no, wait a minute, let's go back to basics. So this 200 picofarad cap shouldn't be anything more than about maybe 10 or 15 picofarad. And I think what had happened is you replaced it thinking it was bad, but the cap that was in it was good. I put that cap back in, and now we have this going on. So we're going to use the bench 2950 here. And if you notice, I got the modulation turned way, way down. We're going to get to that here in a minute. So we turn the mic gain all the way up on this thing. And we're in standby, in AM, in low mode. Okay. So now, here's the 5 watt element between the radio and the amp. Hello, 1, 2, 1, 2, 1, 2. So now let's go down here and let's look at the watt meter. Hello, 1, 2, 1, 2. So this is a 1000 watt element in peak, 1000 in also peak, and a 5 watt slug and reverse back from the Bird 10,000 watt dummy load. Hello, 1, 1. So we want to put about a watt dead key in this thing. After I got the key in circuit working, immediately this diode decided to let out the ghost. And part of the problem that we had was this snubbing diode in the keying circuit. Now, the reason I say in the keying circuit is because the way this board works is it trips the signal from here and it runs it over and it actually keys this relay, which in turn keys the high voltage. This in turn then drops the positive voltage onto this relay here in the back. This relay that's here is our preamp relay. This little brown one right here. So this took a hot minute to figure out. And also on top of that, there was this little tiny diode that was on the keying transistor board. It was backwards. So every time I put power to it, it would blow the keying transistor up immediately. So I ended up changing the keying transistor like 3 or 4 times. Well, here's the problem is when I undo the 2 screws to pull the board off the back and flip it over and change the keying transistor out, I got all the wires that are attached to this board were starting to break off. So repair one, repair another, repair 3 of them. I've made the executive adult decision to go ahead and put the 2905 keying transistor, which is a positive, negative, positive transistor, by the way. I misidentified it earlier. That's the only reason I'm pointing this out. Put it on this side of the board so we can have access to it. We're doing that for good reasons. I'm here to tell you. It is what it is. So I replaced this 600 volt diode with a 1000 volt diode. So we're never going to have this go out on us again. This is a old school 2 amp diode. I replaced it with a 6, so we'll never have that happen ever again. Let's see. 2 of the wires that were on the board were in the wrong spots. I figured out where those went and got that fixed up. And then there was a little bit of a problem with the load tuner, this tuner here, where the fins were actually touching when you get to a certain part when you load the box out. So I went in there and I very carefully with a flat blade screwdriver massaged the fins to now where everything's perfect again. All that aside, then we started having problems with this guy. Let me back this out. So I don't know if you guys remember when we tested the tubes just a few seconds ago. In your world, to me it was yesterday. This was the 53% tube. We're going to write bad on it because it was making this amp jump all over the place. There's an intermittent short that's in this tube. If you'd tap it, you could get it to work for a couple of keys and then it would freak out, the input SWR would take off. So we're going to write bad in big bold letters on this tube. We don't ever want to use this tube. Ever. Ever. So what's in here for the driver is the tube that was at 43%. And that was supposedly out of the brand new 100% new 43% one. Okay. Now, let me show you how this box operates. It makes good power. It really does. But it's incredibly low drive. It's set up for 5 watts max. That's peak. So key at 1, swing to 5. That's it. 8 watts, it starts showing up as reflect. The tube can't take any more input power. So, we come over here. So we're going to stand by. Hello. Hello. We're going to put 6 or 7 watts into this thing. Let me hit the operate switch. No more chatter rattle. And please note the sideband switch is off. We're just in AM mode. Now I want you to adopt this mode of operation. Go to standby, then go to sideband, then go back to operate. Standby, AM, operate. Standby, sideband, operate. Standby, AM, then operate. Okay. So we're in AM. Now with 7 watts of drive in operate. With the 1 watt carrier, you get about a 200 watt, about 125 watt carrier. Hello, audio. With 7 watts of drive, it swings to 800 watts, which is really stinking good for 3 6LF6s. 4 does about 1,000. So you know about every tube is going to get us about 250 watts. It's what we've seen in a billion different amplifiers. They'll do the same thing. So to see 800 watts, we're screaming. Please note, we're seeing it on both meters. Hello, analog and the digital. Now, everybody's crying foul and saying BS. I argue with your logic and I say, let's look at the spectrum analyzer, because the watt meter shows us how much power we're putting out. The spectrum analyzer shows us where we're putting out the power. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2. Pretty clean. We have a principal, and the next one down is 57 dBs from the principal, which would be our second order harmonic at 57 megahertz. Now, let's go look at this. This is our input tune. So we're going to go to standby. This is our pass-through tune at 011111. Here's our input tune at 0111111111. Okay. You remember how I was talking just a second ago about don't put too much drive in it. I want to show you what happens. So maybe people will get a clue. The amp is now in standby. Let's go over here. We'll turn the mic gain up. Hello, 1, 2. So now we're swinging 30, 34 watts into the amp, right? Put the amp in operate. Hello, 1, 2, 1, 2, 1, 2. Doesn't do one more licking watt worth of power. But then we come up here and look at our input reflect. Hello, 1, 2. You see how it starts to come up? Now let me reach over here and I'm going to turn the mic gain down, which is going to effectively mute our output peak power, right? Hello, 1, 2. Hello, 1, 2. All right, so come back down. Now it's nice and good. And back over here. Hello, 1, 2, 1, 2. 5 watt max drive tube, or 5 max watt drive amplifier. That's it. That's all we can put into it. Anything more than that, your input reflex is going to jump up and down. Now, I've said all these fancy words. We have to remember that this amplifier was built in the day when we had a 5 watt radio. If you had a full 5 watt or 10 watt radio, you were screaming. Somebody had been in there and clipped some stuff and moved some stuff and changed some stuff. Right? So today, the world that we live in, everything's a 100 watt radio. So we have to keep that in perspective. We're going to go to standby, put this in sideband, and now we're going to put it in low. Put this back in operate. Hello, 1, 2, 1, 2, 1, 2, 1, 2. 500 watts. That's what it does on low. Standby, put it back in high, back into operate. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Legit. The reason the relay was chattering on you, my man, I'm talking to the owner of the amp. The reason the relay was chattering on you is because the input SWR was so high that it was making the relay unlatch. It was causing the transistor it didn't understand what was taking place in the circuit. And it was all because of this one capacitor and this one diode that you guys had changed out. These two parts. It's the reason it was chattering. Okay? So my friend, you are fixed. This thing is ready to go. This thing does get very warm when you're operating it. I mean, it's making a lot of heat, right? You even got the meter reading right. Hello, 1 2 1 2. Had to take a couple twists out of the circuit. The way this is driven is there's two wires. They're gray and they're twisted together, and it works by coupling. So the more RF that's on one side will couple over and drive this meter. The way it was set up from the factory was when you modulate this thing would run all the way to the corner. Bing, 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 beating the shit out of the meter. So the only thing I have left that I want to do, that I haven't done yet, standby, then off, by the way. Okay. Put this back and operate just to key it so we can neutralize the high voltage circuit. Now it's safe for me to put my fingies in here. I want to put a zip tie around this capacitor. That cap floating loose, it's not supported like this one. I have a feeling that everything's working just fine right now. But on the way home, it might cause this thing to break. So I'm going to take two zip ties and I'm going to zip tie this cap to this cap, like so, to help support it. So we don't have to worry about it vibrating the socks off the part. That being said, I'm going to send this little bag of 2907A transistors. A couple extra key-in transistors just in case. Just in case. And you can reinstall on the board the way this one's in here. There's no high voltage present until I key the amp, by the way. Just in case you have a problem. So we got all the wires moved away from everything so you can get in here with a soldering iron and touch things and move things if you needed to on the keying transistor. Everything else is just the way it was when it was put together. I was very meticulous about how we did this. Yeah, man, this thing's working fine now. Hello, 1 2. Hello, 1 2. Hello. Hello. It's asking a lot out of those three tubes in the final section. That one, and that one. So, if you get yourself a set of new 6LF6s, and you're kind and courteous to this thing, it'll last you for quite some time. I did take the opportunity while I was here, by the way, and I undid the two mounting hardware bolts for the filter bank. Turn the radio off. What am I doing, dingling? Here we go. There we go. Now we're discharged. I did take the opportunity while I was here as I took the two mounting bolts off. I took the high voltage board off and I lifted up one leg on each side of the electrolytics and tested them. These two caps are fine for now. Remember, these are pretty old. These are probably 45, 40-ish years old caps, right? These are good. I checked these as well. I think on your end, after I seen what was going on and finally figured out how to make all this work properly, it was just a series of, I took parts out and we put parts back in, but they weren't the right exact part. Unless you would have put the caps on a capacitance meter, there's no writing on the outside of these that would say what they are. The other one said 500M-51B or whatever BS on it. This one here says MOSET, M-O-S-T-E, and then it says 23985R, 4RCV. This was 200 puff and it needed to be about 10 at the most. So you're in top shape, dude. I appreciate all you guys hanging in here with me and watching this video to the very end, if you guys made it. I really am not a big fan of working on these sweep tube amps. They are twitchy at best and delicate to ship. Jesse, thank you. It was fun to get to work on this for a little bit. Remember, 5 watts. 5 watts. 5 watts. Remember, when you go from operate, put it back in standby and then switch it from AM to sideband. Just because the way this thing is built, if you have it in operate and you switch from AM to sideband, because there's the way the thing is built, you have the chance of blowing up your keying transistor. So remember, operate and you want to go to sideband, put it in standby, then flip it to sideband and come back and hit the operate switch. And you'll never blow the keying transistor out of this thing again. Okay, on that note, I'm out. Gentlemen, I say thank you. I think I'm off to go help my daughter buy new tires for her truck. Gentlemen, my name's BBI. Super shout out to the Patreons. Big shout out to Penna, XS, Siglet, McMahon, Bird, Coaxial Dynamics. Gentlemen, thank you guys. I humbly say thank you. I appreciate you all. I'll see you. Click, click.